Hi, this is Jennifer Reed, and today we're talking about linear and nonlinear functions. Linear functions are functions with a constant rate of change that when graphed, they create a straight line. Let's start out by looking at the equation. So an equation for a linear function is written in y equals mx plus b format. In this case, we have y equals 2x minus 3. And for this equation, our table looks like this. So we plugged in our input values for x as -2, -1, 0, 1, and 2, and we have these output values. What we're looking for in a table for a linear function is a constant rate of change, and that's what we have on our x values. We're increasing by 1. And on our y values, once we plugged in those numbers, we also have a constant rate of change of increasing by 2. So that tells us with that constant rate of change that we have a linear function. If we're looking at just the graph and we want to know if we have a linear function, we can simply look at the shape of our graph. And our graph has created a line. We have a positive slope, and we also have a y-intercept right here at -3. Note that linear functions can also have a negative slope where the line could be coming from left to right and going down. Always read your graphs from left to right, just as if you're reading a book. Now, let's have examples of nonlinear functions. These include exponential, quadratic, and absolute value functions. Nonlinear functions do not have a constant rate of change, but when graphed, they do not make a straight line. You can see that with the quadratic function here, absolute value function here, and the exponential function here in the blue. Quadratic functions. Quadratic functions, in their equations, we have a 2 in the exponent. So here we see y equals 3x squared minus 6. So your clue right here is that number 2 that tells you that we have a quadratic function. On your table for quadratic functions, we are just mainly noting that nonlinear tables do not have a constant rate of change. And we can show you here that we have picked our input values and we have a pattern of decreasing, decreasing, then increasing, increasing. And that will give you a little bit of a clue of a quadratic function. But we'll dive deeper into that in future lessons. For a graph of a quadratic function, they will make a U shape or a parabola. And in this one, we have an opening at the top, and our lowest point or our minimum is down here at the bottom. If our equation had a negative in front of our 3, then our U shape would be upside down, more like a rainbow, and it would open at the bottom and have a highest point at the top, which we would call max. Now let's look at exponential functions. The equation for an exponential function, it looks like this. So y equals 10 times 0.7 to the x power. So our variable is in the exponent in exponential functions. So that's your clue for that one. Again, our tables for nonlinear functions do not have a constant rate of change. And this is something that you'll get into in higher math. And we'll go on in a different lesson to talk more of this. A graph or exponential has a curve called an asymptote that approaches 0, but it never crosses 0. So that's what this shape is right here. It goes down and curves almost touching 0, but never crosses 0. It's infinitely closer and closer, yet never touching that 0. All right, now we've hit absolute value functions, linear absolute value functions. The equation would have an absolute value bar in the equation. So this one is y equals the absolute value of x minus 3 minus 100. So that's what your equation is going to have, those absolute value bars in it. Again, the nonlinear table does not have a constant rate of change. But when we look at the graph for absolute value functions, we see that this creates a V. If we had a negative over here in the front of our equation, our V would open downward and it would look more like a mountaintop or an A. So I think of it as an A or a V because of the absolute value. And that helps me remember which kind of function I have going on. We want to offer that all of our references came, our graphs and our functions came using Desmos.com for a calculator. Thank you.